Hello everyone. Today the class does not meet, so I will just record this video and upload it on the UJA. So and this is our fourth lecture, and in today's class, we're going to talk about first. We're going to review what we have learned in the last class, okay, and then several things to. Actually, it's not new concepts because you have already learned the trigonometry and similar triangles, right angle triangles. But these concepts will be used heavily in our class, very important for the future problems. So I want to just review these concepts in this class all together. Okay, so this is a type of primer for you to solve the force problems in the future. If you think you are very familiar with the trigonometry and right angle triangle problems, that's great. If you're not, you kind of forget about the things you have learned there. This class will be very helpful for you. Okay, and then after that, we'll summarize what we learned today. So the thing we learned in the last class is first about the rigid bodies. You remember we said all the columns and the beams and structures we're going to analyze in our class are rigid bodies. And rigid bodies have two cool characteristics. One characteristic is under a force, rigid bodies don't deform. So do rigid bodies deform under forces? For this question, the answer should be no. Okay, and the second cool feature of rigid bodies is on the rigid body, remember we said on the rigid body like this block, you can move a force, okay, without changing the status of that rigid body. What I mean is, if you have a force pulling this box to the left, and the line of action is crossing the center of this box, and the magnitude of this force is F equals to maybe 10 Newton, okay, that's your original status. And so the cool feature of rigid body is you can transmit this force to another scenario without changing the status of this box. If the box is standing still, it will be standing still. If it's moving at a constant speed, it will move at the same constant speed. But the only condition of moving this force without changing anything is that new force has to be on the same line of action of the old force. Okay, so you're going to move this force to somewhere else, maybe on the right side of this box. You see the line of action is still the same, crossing the center of this box, and the magnitude of this force is still 10 Newton. Okay, so in the second scenario, although you moved the force to a new position, the point of action here is different than the original status. But you move the force along the line of action with the same magnitude, 10 Newton. So because it's rigid body, these two scenarios will be the same. Okay, so that's the cool feature of the rigid bodies. And the third thing we learned is external forces and internal forces. It's very easy to determine which one is external, which one is internal, based on the boundary of the system you defined. Okay, remember our example about that column system. Okay, so sometimes if you change the boundary of your study system, the internal force could become a external force, and vice versa. Okay, and after that we learned what is vector. So vector is a measurement that will tell you both magnitude and direction. Okay, and here the direction is very important because it will tell you where is the vector is pointing at. Okay, and if you remember, a force has three characteristics. One is the point of action, second is the magnitude, and the third is direction. So we can say forces are vectors. Because forces are vectors, so if you want to add up multiple forces, you couldn't just add up the magnitude directly because you have to figure out how do you measure those different directions. Okay, so this is all we learned from last class, and we have one question remained because we know, okay, we couldn't add up forces directly, then how do we do that? Okay, that's the question remained from the last class. And this is also the question we're going to figure out in the next class. So today we're going to do some primer for you to, smoothly learn the addition of the vectors. All right, so as what we said, a force can be divided into its x and y components. We have practiced this in the last class. You remember that? And there are two examples here. So one force is F1. The magnitude is 40 kN. And then in the first case, this force is going up, okay? And the angle of that force is 45 degrees away from the x-axis, okay? Just recall, how do we divide this force to its x and y component? First, you want to set up this Cartesian coordinate system. So in the Cartesian system, you have origin point, 0, and then that's where the x and y axis intersect. So, and then also you have the x-axis horizontal and y-axis vertical, right? So that's how you set up this Cartesian system. And you want to draw this x-axis with this dashed line, okay? You also want to draw the y-axis with the dashed line, okay? And then you want to find the tip of that force. This is the tip, okay? And then you want to draw another dashed line which is perpendicular to the x-axis. And the way you tell me it's perpendicular is you have to label this angle with this kind of, square, small square, okay? And that means this angle is 90 degrees. And we call this two dashed lines, the two dashed lines, we call them, they are perpendicular to each other, okay? So perpendicular is a term you have to be familiar with. We're going to talk about that, use this term a lot. Okay, and then, so once you have this perpendicular line done, you can find the end of your x component, okay? Draw the arrowhead, and then starting from origin, and then draw along this x-axis with a solid line. We always use a solid line as a known force, okay? This is a solid line. And you want to label it as F1x. F1x means it's an x component of F1. So you can imagine in the future there might be multiple forces. So you have F1, F2, F3, and then on the same graph, you're gonna label them as F1x, F2x, F3x, da da da. Okay, so just practice this. How do you label the force? All right, then let's do the y component. So you still start from this tipping point, okay, and then you draw a perpendicular line, okay, 90-degree, and then here is where your y component ends. So draw this arrowhead and then connect the arrowhead with the origin, okay, and label that as your F1y. So this is how you divide the F1 into its x and y component. And you can see here actually we draw a rectangle here. Okay, so this is the rectangle we just draw. And we use this method. We always use this method, okay? So in the second case, just try to practice by yourself, okay? So again, we want to set up the Cartesian coordinate system first. Okay, so you got this 0, that's your origin, and then you draw this dashed line, horizontal, which is your x-axis, and then you draw this, that's your y-axis. Done. Okay, set up the system first, and then you can tell, okay, on this chart the F1 is still 40 kN, but the degree now is 30, so it's the angle between the force line and the x-axis is 30. And then you want to find the x component of F1. The way you do that is you start from this tipping point, you see that? Okay, and then you draw a line perpendicular to x-axis, okay? And then that's where your x component ends. So draw this arrowhead, and then connect your arrowhead with the origin, and label that as F1x. Next, starting from this tipping point, you see that? Okay, again, but now let's draw a line perpendicular to y-axis. Okay, and then that's where your y component ends. Draw the arrowhead and then connect the arrowhead to the origin, and then label that force as F1y. Done. So this is how you divide a force into its x and y component. Okay, just practice this, and you will handle this problem very well in the future. All right, so let's talk about the Cartesian system. Okay, we said, okay, you draw the horizontal line as the x-axis, you draw the vertical line as the y-axis. Okay, that's the very traditional Cartesian system. Okay, and we always want to label or define the force direction based on the line of action of that force. Say this is the force based on the line of action of that force and the x-axis. So the angle here, this is the very common way for us to indicate the angle or the direction of the force. But the second thing about the Cartesian system is, well, it does not need to be, always be horizontal and vertical. It depends on your study system. Okay, let me give you an example. So if you are studying something on the ground, okay, like this. So, well, it's very natural for you to set up a Cartesian system like this, right? And but if you are looking at some slope, say if you have a surface which is a slope, and there is an angle given for this slope, maybe that's 30 degree, that's your new ground. It's not a horizontal ground, it's angled, it's a slope. So if you have another object on that slope, and then you have a force going down like that, maybe for that object you have a weight going down like this. Okay, let's label it as weight. So in this case, you can set up a Cartesian system which is like this. So your x-axis is not horizontal but parallel with the slope. And in that case, your y-axis will be always perpendicular to the x, which is also perpendicular to the slope. So that's your y. Okay? So this is the case where you don't need to have horizontal and vertical system. You can adjust that based on the slope. And we will see problems like this, and you will know how do we figure it out, okay? But here, you just need to know, okay, you don't always need to set up a Cartesian system horizontal and vertical. It's not necessary, okay? That's one thing you need to know right now. All right, then now let's just review some trigonometry concepts and rules, which are very, very important for our course, okay? Well, if you know more about this trigonometry rules, that's better. But if you don't have the resource to know everything, or it's really a hard time for you to learn the trigonometry before, the content I introduced in this class is the minimum thing you have to know about trigonometry for our class, okay? So pay attention to the content. The first thing we need to know is right angle triangle, okay? What is right angle triangle? Say triangle is composed of 3 sides and also 3 angles, okay? If you have one of the 3 angles equals to 90 degree, like in this triangle, one of the angle is this. Did you remember this symbol, this small square? We use it for 90 degree, so which means this is 90 degree angle. So if one of your angles in the triangle is 90 degree, we call that triangle right angle triangle. Okay, right just means there is a 90 degree angle there. All right, and then that's the first thing, okay? And then the second thing is you need to know there are names for the 3 sides. So what is opposite side? Opposite side is, if you know an angle is alpha, like in this, so the side which is opposite to this angle, which is opposite, what does opposite mean? This is the opposite, okay, face to face. So this edge will be the opposite side of alpha, okay? So side A is the opposite side of alpha, okay? Angle alpha. And then we can also say side B is the opposite side of which angle? Side B is here, okay? Face to face, what is the opposite angle, which is beta? So next time, if I say, okay, if I say opposite side of angle alpha, you have to quickly respond that that side is side A, okay? This has to be very quick. And okay, another concept is adjacent side. Adjacent side is the side next adjacent to that angle. So let me see if I can change the color. Okay, let's use another color here. Okay, so talking about adjacent side, first you have to find an angle. So let's say if we are still looking at the angle alpha, and the adjacent side of alpha is where? Adjacent this edge, okay? So side alpha, no, side B is the adjacent side of angle alpha. And now let's look at the beta. Beta, what is the adjacent side of beta? Adjacent side of beta is this. Okay, so that's side A. Side A is the adjacent side of angle beta. Then you might ask, like, why? Well, there are two sides adjacent to beta and there are two sides adjacent to alpha. Then why do you just say one of the side is adjacent or opposite? Well, because for this side, okay, for the side C, we have a name for it. It's called the hypotenuse. Okay, so in a right angle triangle, we always, if we say hypotenuse is always this, the longest side in the right angle triangle. And the other two sides, they have a name like opposite side or adjacent side depending on which angle you are looking at. Okay, so these are the names, the naming of the three sides. And you want to be familiar with this. And whenever we say alpha's adjacent side, it's B. It's side B, okay? You have to respond very quickly. So alpha's opposite side, A. Beta's adjacent side, A. Beta's adjacent side, opposite side, B. Hypotenuse, C, okay? Practice this. All right, and then let's do some sine, cosine, and tangent calculation. Okay, let me change it back to the red color. Okay, so look at this right angle triangle. So we have one angle 90 degree. We have one angle alpha, which is 30 degree. We have another angle beta, which is 60 degree. And it's also given, what is also given is the hypotenuse. C is 2, the length is 2. And another side A, the length is 1. And the third side B, length is square root 3. Okay, that's all the conditions given. And now let's try to calculate what is sine alpha. Alpha is here, okay? The sine alpha is, try to recall what you have learned. The sine alpha is the opposite side of alpha over hypotenuse. So the opposite side of alpha is A. Okay, over hypotenuse, which is C. A over C. Okay, so and the value of A and C is 1 over 2. So sine alpha equals to 1 over 2. Okay, and how about cosine alpha? Cosine alpha is the adjacent side of alpha over hypotenuse. Adjacent side is what? Adjacent side of alpha is what? Is B. So B over hypotenuse C. And the value of B, square root 3, hypotenuse length 2. So cosine alpha is square root 3 over 2. Tangent alpha. Try to recall what is tangent alpha. Tangent alpha is the opposite side of alpha over the adjacent side of alpha. Okay, so opposite side of alpha is A, adjacent side of alpha is B. Okay, so this is A equals to 1, B equals to square root 3. All right, now let's turn to angle beta. Okay, so sine beta is what? Is the opposite side of beta over the hypotenuse. So the opposite side of beta is B. Hypotenuse is C. So B over C, and B equals to square root 3, C equals to 2. Then sine beta is square root 3 over 2. Cosine beta. Cosine beta is the adjacent side of beta, which is A, over hypotenuse. And A is 1, hypotenuse is C, is 2, so it's 1 over 2. And next, tangent beta. Tangent beta equals to the opposite side of beta over the adjacent side of beta. Opposite side beta B equals to square root 3. Adjacent side of beta equals to 1. So this is how you calculate sine, cosine, tangent. Okay, well, you have to review your class notes from trigonometry, try everything to remember this. Okay, and I can write the rule here on the right corner. And I know there are something called SAGTOA. That's something other teachers teach the student how to recite this. So you can use any ways to help you recite this sine, cosine, tangent of an angle. Well, my way is I always connect the sine of some angle equals to sine always equals to the opposite side. Okay, of alpha over the hypotenuse. And cosine is always related to the adjacent side. And tangent is always starting from the opposite side. And on the bottom of this bar, it's always adjacent side. Okay, so that's how I recite everything. Okay, now here are some figures you need to recite. the sine, cosine, tangent, and the cotangent of some special angles. Okay. Excuse me. Okay, let's just do it together. Fill this table. Okay, the sine 0 equals to 0. Okay, and cosine 0 equals to 1. Tangent 0 equals to 0. Cotangent 0, well, there is no value available. Okay, and sine 30 degree. Sine 30 is 1 over 2. And cosine 30, or you can say, okay, 0.5, okay? And cosine 30 is square root 3 over 2. Tangent 30 degree is square root 3 over 3. And cotangent 30 degree is square root 3. And for 45 degree, sine 45 degree is square root 2 over 2. The cosine is the same, square root 2 over 2. Tangent 45 degree, 1. Cotangent 45 degree, 1. Okay? And 60 degree. Sine 60 degree is square root 3 over 2. Cosine 60 degree is 1 over 2. Tangent 60 degree is square root 3. Cotangent 60 degree is 3 square root 3 over 3. 90 degree. The sine 90 degree is 1. Cosine 90 degree, 0. Tangent 90 degree, not available. Cotangent 90 degree, 0. Okay, so these are some special values you have to, just recite. So in the future calculation, you don't have to always use the calculator. Okay. Okay, another thing. Okay, now we need to learn how to solve for one missing edge or missing angle in a right angle triangle. Okay, so here are some examples. And the first example here is in this right angle triangle, given hypotenuse length C, so C is given, and the angle alpha is given. So given C and alpha, how do you solve for B? Okay, what is the B, the length of B? Okay, so here you want to use the sine alpha. Remember, we said sine alpha equals to, wait a second. No, you want to use the cosine alpha, okay? Excuse me here. Okay. Because the side B is adjacent side of alpha, so you're going to use cosine alpha. We said cosine alpha equals to B over C. Remember that? So if you move the C to the left side, you can have another equation like B equals to C times cosine alpha. See? And then now you learn from the condition C is 2, alpha is 30 degree. And now you have 2 times cosine 30, we just listed here. Cosine 30 is square root 3 over 2. Square root 3 over 2. Now, what is B? B is square root 3. That's it. So, the B equals to the hypotenuse times cosine alpha. Okay. Now let's do this example. Okay, the given condition is C and alpha 30 degree. Now you need to figure out the length of side A. Side A is the opposite side of alpha. So in the calculation, you're going to use the sine alpha. Okay? And so here, the side A equals to C times sine alpha. C is 2 sine 30 degree. 2 times sine 30 is what? Sine 30 is 1 over 2, okay, a half. So 1 over 2. Now your A equals to 1, right? So this is why I said you always want to associate sine alpha to its opposite side. And cosine alpha, so sine some angle always associated to the opposite side. And cosine alpha always associated to the adjacent side. That's how you can do this calculation very quickly. So here you want to know side A, and A is what? A is the opposite side of angle alpha. Okay, so opposite side of an angle, well, okay, it's associated to the sine of that angle. That's how you think in your mind. You don't have to write it down, but that's how you solve it in your mind. Then you can use the hypotenuse times the sine. Okay. The third example. Now, the given condition is the side B, which is the adjacent side of alpha, and alpha, which is 30 degree. Okay, think about that. Adjacent side always associated with what? With cosine. So you are sure cosine is something you're gonna use, okay? But here we're looking for the hypotenuse. So it's not a edge times the cosine. It's gonna be the adjacent side divided by the cosine. So the C, remember we said cosine alpha equals to adjacent side B over C, right? And then if you want to solve for the C, you want to move everything to the left side. So C equals to B over cosine alpha. So here, our solution is C equals to B over cosine alpha. And the B is square root 3. Cosine alpha is what? Cosine 30 is square root 3 over 2. Square root 3 over 2. Okay, and then the answer is 2. So C is 2. Okay, let's try this. Now what is given is the side A and also the alpha. Okay, and now you're looking for the hypotenuse C. So because the side A is the opposite side of alpha, so you're gonna think, okay, the thing I will use is sine alpha somehow, okay? But because we're looking for the hypotenuse, it's gonna be the edge divided by the sine. So it's A divided by sine alpha. A is 1, sine alpha is sine 30, okay, sine 30 degree. So 1 over 2, which is 2. Okay, here, this example is in the right angle triangle. What is given is the side A and the side B. What is the alpha? Okay, remember we said tangent alpha is opposite side over adjacent side. So 1 over square root 3. So if you know tangent alpha equals to 1 over square root 3, what is the alpha? You're gonna use the arctangent. Okay, so on your calculator, you're gonna find this button, and the value you want to put here is tangent alpha. Okay, this is how you calculate the alpha. And if you are using your scientific calculator, you also want to first set up your angle mode in degree, okay? Because sometimes it's radian, so you want to change that to degree. And then you're gonna find tangent, arctangent. This is the button you're gonna use, okay? And then do the calculation. And if you do that, you can see that the answer is 30. Okay. Okay. One more example here. Say, in the right angle triangle, you know the two legs next to the right angle, the side A, which is 1, side B, which is square root 3. How do you calculate side C? Okay. To do this, you have to know Pythagorean theorem. Do you remember this Pythagorean theorem? This theorem tells you the relationship between the three sides of a right angle triangle. So the square root of the two legs, the sum of this value equals to the square root, the square, okay? The square of the two legs, the sum of the square of each leg equals to the square of the hypotenuse. So in this right angle triangle, a squared plus b squared equals to c squared. And how do you calculate c squared? C squared is square root of a squared plus b squared. Okay, that's something you need to learn. And then a is 1, b is square root 3. So 1 square is 1, square root 3 square is 3. So your c is square root 4, which is 2. This is very, very important, okay? And the next thing is you want to recite some special triplets that make right angle triangles. So if you know the two legs of a right angle triangle is 3 and 4, you have to respond quickly that the hypotenuse is 5, okay? If you know the right angle triangle, the two legs is 6 and 8, then what is the third side? 10, okay? So you have to recite all of these triplets. So 3, 4, 5 is a right angle triangle. 6, 8, 10 is also a right angle triangle. And 5, 12, 13, okay? 8, 15, 17, 7, 24, 25, okay? So these are very common triplets, common right angle triangle. So try to remember this. And next, there are some rules of angles we will use. So angles on the straight line add up to 180. So in this case, the green angle is 55, and the angle next to it, the orange angle, is gonna be 180 minus 55. Okay, because these two angles, they are on a straight line. And the second case is angles at a point add up to 360. Okay, so in this case, we know the three angles, orange angle, green angle, and the blue angle, they are around a point. So given the value of the two angles, you can calculate the orange angle is 360 minus 92 minus 151. Okay, that's angles at a point. And vertically opposite angles. Okay, so if you have two lines, they intersect with an angle, and then the opposite angles, they are equal. So if you know one angle is 36 and its opposite angle is also 63. Excuse me. Next, angles in the triangle add up to 180. Okay, so in a triangle, any triangle, the three angles, they add up to 180. So if you know angle 1, angle 2's value, you can calculate the angle 3's value is 180 minus 47 minus 52. And a special case here is our right angle triangle. Say if you have this right angle triangle, okay, A, B, C, and you know angle A is 30. Then what is angle B? Angle B is 90 minus 30, which is 60. So in a right angle triangle, the sum of the two non-90 degree angles is always 90 degree. Okay, that's the rule. So angle A plus angle B is always 90 degree. And the next rule is angles in a quadrilateral add to 360. Okay, so and in a parallelogram, opposite angles are equal. So this is a parallelogram. Okay, and opposite angles, this is opposite angles, the two blue angles, they are equal. And also the two green angles, they are equal too. That's the opposite angle rule. Okay, now let's talking about the parallel lines, rules about parallel lines. So here we have two lines, they are parallel to each other, okay? A traversal creates three letters of the alphabet, which hide three new rules of angles. So if you have two parallel lines and you have a transversal, you're gonna have this 1, 2, 3 new rules. Okay, so what is the Z angle? Z angle is the two angles over here, the blue angles, okay? And they are alternate angles. They are called alternate angles, and they are equal. And we got another two angles, okay? They are called corresponding angles, and they are also equal. And the third, interior angles. So the angle inside of this parallel line, the green and the blue, they are called interior angles, and the sum of these two angles is always 180. These three are very important rules in our course. Okay, try to remember this. Next, let's learn similar triangles. So similar triangle, what is similar triangle? Similar triangles are two triangles. The value of their corresponding angles are the same. Say, in this triangle number 1, we have three angles, angle X, angle Y, angle Z. And we find another triangle over here. It also has 3 angles, and the value of one angle is also angle x. The value is the same. And there's another angle y. Its value is still the same as the first triangle. Okay, so this same value, these two same value. Of course, these two are the same value. And if we got two triangles like this, we can call them similar triangles. And corresponding angles are equal. Okay, so based on this, we can also say there are corresponding sides. So the corresponding sides are the sides between the same pair of angles. In the first triangle, side C is between angle X and Y, right? So its corresponding side in the second triangle is what? Is another side which is also between X and Y. So the first question, what is side C's corresponding side in the second triangle? Answer is F. Same thing. What is the side A? The A's corresponding side in the second triangle? D. Okay? Because A is between angle Y and Z, D is also between angle Y and Z. So they are corresponding sides. So the answer for the second question is D. Then the third question, what is the side B's corresponding side in the second triangle? So B is the side between angle X and Z. Its corresponding side in the second triangle is gonna be E. And a cool feature of similar triangle is the ratio between corresponding sides are equal. So the ratio is here. So A and D, their corresponding sides, the ratio between them equals to C over F equals to B over E. Okay, so this is the ratio. They are equal. That's a very cool feature of the similar triangles. All right, now let's look at these two similar triangles. Okay, look at the second triangle on the bottom. Well, it's the angle Z is on the left side of that triangle. It's different than the first than this case. Okay, so it's hard for you to find the corresponding angles just from a look. You really have to investigate. Okay, so in the first triangle we have angle Y, the green color, and in the second triangle we also have that angle Y. And in the first triangle we have angle X on the left side. In the second triangle, on the left side it's not X. This is not X, but here is the X. Okay, so it's just in a different position. Okay, it's on the right side. That's fine. And then in the first triangle we have angle Z, and then in the second triangle we have another angle Z, which is on the left side. It's still fine. Okay, so the position of the three angles, it doesn't matter. It only matters if the values of the three corresponding angles are equal. Okay, and okay, although the positions are not the same, we still have similar triangles because the three pairs of angles are the same. Now, let's look at the corresponding side. It's a little bit trickier. So what is the side C's corresponding side in the second triangle? Side C is here. Side C is between X and Y. Okay, angle X and Y. So you have to find in the second triangle what is between X and Y. Is it P? No. P is between angle Z and Y. Well, that's different. So who is between X and Y? R. So C's corresponding side will be R. Okay, that's the right answer. And second, what is the side A's corresponding side? Well, side A is here. It's between Y and Z. Then who is between Y and Z in the next triangle? Oh, it's P. Okay, so it's P. Third, what is the side B's corresponding side in the second triangle? Side B is here. It's between X and Z. Okay, in the second triangle, what is between X and Z? It's Q. Alright, so because the position of the corresponding angles are different here, so it's a little bit trickier to find the corresponding edges. But you always want to remember the corresponding edges or the sides are the sides between the same pair of angles. That's how you find it. Okay, the same thing. The ratio between two corresponding sides are the same for the similar triangles. So here, A over P equals to C over R, because C and R are corresponding sides, equals to B over Q. And this is the same ratio. Okay. All right. So let's recall what we have learned about the right angle triangle, and this is the thing we're going to use for our calculation in the future. Okay, so remember, we have in the right angle triangle we have C as the hypotenuse, and given the angle alpha, we can always find the side A and the side B. How do we do that? Side A is the opposite side of alpha, so it's going to be associated with sine alpha, right? So A equals to hypotenuse times sine alpha, right? And if the length of C and the value of alpha is given, you can just put them into the equation and find the value. Okay. And side B is the adjacent side of alpha, so you're going to use cosine of the alpha. And then B is hypotenuse times cosine alpha. That's it. That's the right angle triangle. Now let's move on to the fourth problem. Okay, think about this force. We said the force can be divided to its x and y components, right? So how do we divide it? Do you still remember that? You set up this Cartesian coordinate system. Okay, you have origin, and you draw the dashed line horizontally, and that is your x. And you draw another vertical line, which is your y. Okay, and then you find the tip of that force over here, and then you draw a line perpendicular to x-axis, and then that's where your x component ends. You draw the arrowhead, and then you connect the origin to the arrowhead with a solid line. Label it as fx. And you do the same thing to find a line perpendicular to y-axis. Label it as 90 degree, and here is where your y component ends. Connect that arrowhead to the origin and label it as fy. Okay, now because we said this is a huge rectangle, right? So rectangle, the opposite side of the rectangle is the same. They are equal. So can you imagine this is the same length of your fy? Okay, let me use another color here Okay, so you can move your Fy over here, something like that. And you still can say the magnitude of this is still Fy, right? Because it's a rectangle. The opposite sides are equal. So you can do that. It doesn't change the magnitude. So now you can see we developed a right angle triangle, the black one, with Fx, and Fy. So the force and its two components, the three of them can build up a right angle triangle. That's very cool. And because of this, you can solve for the Fx and Fy using the right angle triangle rules. Remember that? So look at this black right angle triangle. Does it look familiar? From this, they are the same. Okay? And then if you say A is C times sine alpha, B is C times cosine alpha, what is Fy, what is Fx? Fy is just like the A here, okay? So Fy equals to hypotenuse in this triangle is F times Fy is the opposite side of alpha, so it's gonna be sine alpha. And Fx is the adjacent side of alpha, so it's hypotenuse times cosine alpha. Look at that. This is exactly the same, right? So if you know how to solve for a right angle triangle, you're gonna know how to solve for the two components of a force. Just to build a right angle triangle by the three elements, the force itself and the two components. Okay, and this process of finding x and y components and build up this right angle triangle and solve for the two components, this whole process is called force resolution. So if I say force resolution or resolution of a force, you have to think, okay, that's the thing I need to divide the force to its x and y components and then calculate the value of them. Okay, force resolution, very important. Okay, now let's do an example here. Oh, this is not an example. This is another concept, the ways to indicate the direction of an angled force. Okay, so for now, we just use an angle like a degree, 30 degree, 60 degree to indicate the direction of a force. But in some cases, the degree is like, it's not integer. It's like 22.6. And another way we can indicate the same degree is to use something like this, like a slope, okay? So it will give you a label like the two intersecting lines perpendicular to each other, and then it will label the lengths over there, 12, 5. That's one way to label, to indicate the angle. Remember, we said you want to remember the triplets. So here, this is the triplets. If you have a right angle triangle and you have two legs as 5 and 12, what is the hypotenuse? 13. You have to write this very quickly, okay? And once you know this, look at that. This is, so if you want to build that triangle, right angle triangle, using the two components, okay, this is something you can have. This is the right angle triangle, And also, you can move the x component to here and keep the y component on the y-axis and build up another right angle triangle. You see that? So the red triangle is also composed of the three elements, the force itself and the two components. Amazing. And why do you want to compose something like this instead of the black triangle? Because you want to use this as a similar triangle of this. Can you tell they are similar triangles? Right? That's how you build these two similar triangles. And the cool thing about similar triangles is if you know this three edges, you can find the corresponding edges or corresponding sides. Okay, so your Fy, Fx is gonna be two corresponding sides of edge side 5 and side 12. So remember we said the ratio between corresponding sides are the same. So you can tell Fy over 5 equals to what? Equals to Fx over 12 because they are corresponding sides and they are equal. So this is also very important. And also another thing important is in similar triangles, the corresponding angles are equal too. So this angle is equal to this because they are corresponding angles. Okay, very important here, the way you can indicate the direction of angled force. We're gonna practice more in the future problems. Okay, this is another example of showing the angles with the slope with the similar triangle here. Okay, so what is the similar triangle you can build up with the elements? This is the one. Okay, so this red triangle is the similar triangle of this small one, 3, 4, 5. Okay, and also this red triangle is built up by the three elements of the force TCA. Okay, so this is the force TCA's x component, and this is the y component. Okay, actually you just moved this TCAY over here to build up this right angle triangle. Okay, very last, let's do an example here. So we have an anchor bracket. It is acted upon by a 1,000 pound force. This is the force, 1,000 pound, at an angle of 30 degrees from the horizontal. 30 degrees. So determine the horizontal and vertical components of the force. Okay, so the way you do it is, first you draw a Cartesian system like this, okay? And then you put the action point of the force at the origin. Okay, that's your action point, right? You put it at the origin like that, and then you draw the force just like what is showed in this graph, and label it as F equals to 1,000 pound. Okay, this is just to isolate this force in a Cartesian coordinate system for your analysis. And this angle is 30 degrees. Okay, now let's do the resolution. The first thing is, okay, you already set up this Cartesian system, so you have already done the first thing. And then you want to find the two components by doing the perpendicular line. Remember that? And then draw the solid line between the origin and the arrowhead and label it as fx. And do the same thing to find your fy. Okay. Now you want to calculate what is fx, what is fy. You have to build up that right angle triangle, okay, for the analysis. So the way you build it up is, you already know this angle is 30, so you want to include that angle in your triangle. Then you just want to move the fy over there and label it. So now this black triangle is your target, okay? And then your fx equals to, because fx is the adjacent side of 30 degrees, so it's f times, adjacent side is always associated with cosine. So f is 1000 times cosine. We said cosine 30 is square root 3 over 2. So it's 500 times square root 3. And you can use your calculator to calculate what is the result. Okay, let me check the final result for this. So cosine 30 this equals to 866 pound. Now, what is the fy? Fy is the opposite side of 30 degrees, so it's f times sine 30 degree. It's 1000 pound times a half, which is 500 pounds. So this is your answer, okay? Fx and fy. All right, then let's do the summary. Okay, what we have learned today. We said, okay, we want to set up a Cartesian coordinate system of x and y axis, but we said it's not always need to be horizontal and vertical. Sometimes it can be parallel with a slope, okay? And second, we reviewed some trigonometry concepts and rules. We want to learn how to solve for a side or an angle in a right angle triangle. And third, we learned what is the resolution of a force. The process is, first you set up the Cartesian system, then you divide the force to x and y components, and third, you build up a right angle triangle with the 3 components, and then you solve for the 2 components, x and y components of a force. The whole process is called a resolution of a force. And the last, we learned the different ways to indicate a slope. So you can indicate the slope by degrees, like the angle between the line of action and the horizontal line. You also can indicate that with the symbol like this. Okay, 3, 4. If you have something like this, you need to quickly respond that the hypotenuse is 5. That's why you need to remember those triplets. Okay. All right, so this is all for today. And I want you to just, practice the thing, and then try to recall what you learned from trigonometry. If not, just remember the things we have introduced today, because that's the bottom line, the minimum content you have to know for the future class.